What's up, everybody? Today I'm doing something a little different. I wrote a blog post about Cloudflare's network, rather thinking in the network and not in data products or products. And I want to go over this blog post and show the animations because it was very helpful for me and maybe will also be helpful for you. Oh, I'll just show you. Before we start, Cloudflare makes the most sense when you keep this network in the back of your mind. Right? When you deploy a worker, it can go to any of these co-locations. Sometimes multiple of those, right? And that is like crucial to understand. Okay, so the blog post is called "I was thinking in databases. I should have been thinking in networks." I'm not going to read the blog post. Like I said, I'm just going to go over some of the diagrams and then I hope you'll read it maybe in your own time, or maybe you don't even need to. Let's start with the first one, KV, right? Key value storage. Super simple API to set a new key and a new value and a time to live. But what actually happens when you press save or when this runs? And what happens is there's these central stores. And when anyone in the world tries to read from one of their co-locations, if it's what we call cold, the dot will be blue and it will go to the central store, go back, and it will store it in the co-location, in its cache, so that the next person around here will get that data. And that's why KV is so fast all across the world. And it's not just like a single Redis instance that you would have on a VPS. So why is this interesting? We say, oh, it's eventual consistent and don't use it for rate limiting. Well, why is that? Well, if you set a rate limit and somebody is getting it from an old value from the cache, you're not rate limiting them. You want to use either rate limit or durable objects for this. But we'll get down to it later, but see how KV makes sense in the sense of this network. Now the same goes for D1. And D1 is like the SQLite database from Cloudflare. It's not exactly SQLite, but it's very similar. You can have up to 50,000 databases, but only one database can only be 10 gigabytes. And this is actually, I think, something we need to tell people more. Like once it starts to hit 10 gigabytes, yes, you can make another database, but you have to create a binding and release it. And if your database is going to grow past 10 gigs, I probably wouldn't use D1, to be honest. But under that, it's amazing. And 10 gigabytes is a lot depending on your product. How does D1 work in the context of a network? Well, when you create a database, you have to provide a location hint. So, and here I have a location hint that's like Eastern America, and that's where the primary database will be. And everyone who's reading or writing from this database will actually make a round trip to this location. So it might be fast for someone in the US, but it might be slower for someone in the EU. However, we need to think in the context of Cloudflare's network. So if I turn on read replication, now all the writes will still go to this primary database, but actually will sync replicas to a bunch of other locations. So now if I'm in Europe, and I do a read query, let's say select users, we're super fast because it goes to the read replica and not the primary. And you can do this using the sessions API, where you create a bookmark, you have a session, you just replace your envdb with session, and then you return that session ID again here. When you make another query, it goes to that same database. Okay, so we got KV, we got D1, Hyperdrive. So earlier I said, okay, 10 gigabytes, I probably wouldn't use it if I go past 10 gigs. I would use Hyperdrive, or I do use Hyperdrive with PlanetScale. If I have this 10 gigabyte limit, then maybe a full-on database, either Postgres or MySQL, is a better match. However, you still want to leverage Cloudflare's network, right? When you're building workers or you're just building apps on Cloudflare. Well, that's where Hyperdrive comes in. Here you see, okay, I have the main database, this purple thing here in the US, and then there's some connection pools, one in America and one in Europe. Two things are happening. One, if you turn on cache queries or query caching, then actually if I make a read request here in Europe, it will go to this copy and I will get a data from the cache. So even if you're not implementing a real caching layer like KV or Redis, we know they're different. Having a query caching on is pretty beneficial because you can set a time to live, let's say 15 seconds. And if you have a very popular page that does a lot of read queries, like, do you need to hit the database every time? Is the data okay for like 15 seconds? So yeah, Hyperdrive, I did a video on it as well that it's linked here. Oh, one thing I forgot to mention. The other thing that's important about this is the connection pool. And the connection pool is, since these databases are on the internet, right? PlanetScale is an internet database. You connect over the internet usually. And every request, you have to do the TCP handshake, set up SSL. Honestly, this is not my area of expertise. I'm going to be honest about that, but it does take, and you can read this in the Hyperdrive, it does take 6 back and forth handshake, trips in order to establish the connection. Anyway, Hyperdrive, awesome. Next, durable objects. I call them the illustrious durable objects. They're pretty new, as in a new paradigm. I mean, it uses the actor model. It's not that new, but they're it's different from a database like SQLite. Each durable object is instantiated in one location and it stays there. So here I have some code, right? It's a durable object. And this code comes from our guide. We have a rules of durable objects here. And it shows you the full code. I've just condensed it where we have a durable object. And this is just to give you some context. What does that look like in the network? Well, here we have a new durable object and it's in the US. And all requests go to this durable object. Now what if I create a new durable object? Boom. Now they all go here, right? And I create another one. They all go here and they stay here too. Durable objects, once they're instantiated, they stay at that colocation. This might change in the future, but for now, this is, they stay. And then finally, the last product I want to talk about, R2, is probably one of the most popular ones as well, because it's similar to S3, except you pay no egress fees, right? So downloading is free. What does it look like? You have your central storage. So we have this one here, and it will be replicated to another storage inside of the same region for durability and disaster recovery. But most of the data is only stored in one bucket. It's not really replicated to buckets all across the world. However, we do have read caches, which means that if I'm in Europe and I want to download something from R2, first I'm going to make a metadata request to my storage bucket, and it will probably say like, oh yeah, this is here. And then it can be downloaded from a cache. Here we have a cache and kind of looks like southern France. It's a pretty nice location. So you still have fast downloads because they're cached at this location. Not always. So they might be slower. But it's important to know that R2 is you select a bucket or you provide a location hint, and that's where your bucket is stored. Whew, I hope I didn't go too fast. This is like a new format. Like I really learned a lot writing this post. And I thought maybe it's helpful by going over it once. I hope it's helpful for you too. As a fun fact, I recorded this before, but the screen recording didn't work. So I had to record it again now. So I hope my enthusiasm was still on par. But yeah, let me know if this was useful. If not, this is on my personal channel, of course. I'm trying to do some more casual stuff like this. And yeah, thanks for watching.